Hey everyone, today we will be focusing on the transportation problem and using the greedy algorithm how we could obtain the most optimum cost of this table. So first of all, we have source, demands, supplies. So what we want to do is we're gonna go ahead and build the chart. Okay, these are just the prices of each store. Okay, and we're gonna use something called the northwest corner method. The northwest corner method is useful for charts like this where we want to find a solution, but it's not the most optimum solution. It's not the cheapest solution, but it is a solution. And the reason we do that is because we can build off of that solution to get the most cheapest or minimum or optimum cost of this chart. So here we have our prices, our supplies, and our demands. I'm gonna just say S, D, and these are the prices. So in the northwest method, what we do is we're gonna start from the northwest corner, the top left corner, and give the supplies to meet the demands. Okay, that's all we do. So over here we have 50 supplies and 20 demands. So we're gonna meet the entire demand of this column one using the row one, the supply one. Okay, so we're gonna do the same thing here. We want to meet the entire column. We want to feed the entire column. So we're gonna give another 20. But notice how we're eating up. This was 50, and the first time we used it, this became a 30, and now it's a 10. So we need to keep that in mind that we have a limited amount of supplies as well. So this can, as maximum, go up to 10. Okay. So we cannot go any more than 10. So we met the demand of column 1 and column 2, and now we're trying to meet the demand of column 3. Well, this is pretty simple because we have 40 demand left, and the total is 40 also. Like the first row and the second row, they also have 20 supplies. So the best thing we can do here is give 20 here and give 20 here. So we would be meeting the 40 desired demand. Okay. So now that we have this chart, we're gonna try to find the cheapest. So just to keep in mind what our price is, and for a good illustration, our price sets will be 4 times 20 plus 5 times 20 plus 3 times 10 plus 6 times 20 plus 3 times 20. And this will be 60, 120, 30, 100, and 80. And if you add these up, 200, 330, and 390. $390 is our total cost for this initial set. Okay, but what we want to do is we're gonna find the most optimal. Okay, so we're gonna say U1, U2, U3. These are variables that will help us get to the cheapest solution. So U1 is arbitrarily designed. We always assume U1 equals to 10. In other sources, you might encounter U1 equals to 0, but that will change things a little bit. So please try to use this method if whichever one you're comfortable with. Now that we have U1, the way we find V1 is very simple. You go to the price you used. Okay, the ones we use are 4, 5, 3, 6, 3. Okay, these the ones with the circles on it. We can only work with those. Okay, so you're gonna go ahead and use U1 and add that to the price to get V1. Okay, so V1 will be 14 because 10 plus 4 is 14. U1 is 10 and the price is 5, so V1 will be 15 and 10 plus 3 will be 13. Okay, and U2 and U3 can come from the same logic. We're going to subtract 6 from V3 to get 7 and do the same thing and get 10. So these are the variables we're going to work with. So we're going to go to every single unallocated. Unallocated means the ones we did not use. Unallocated prices. So The unallocated prices are 7, 6, 4, and 5, so we're gonna go to 7. Okay? In parentheses, just write the difference of V1 and U2. The difference of V1 and U2, V1 minus U2. Okay, don't get the magnitude because negative numbers can exist here. We're not getting an absolute value, so just do V1 minus U2. Or the respective v value minus the respective u value. Don't get it fixed because the values will change, as you can see. You will see soon. So v2, now the respective v and u will be v2 and u2. So we're gonna say 15 minus 7. Okay, we're gonna do the same thing. 14 minus 10 and 15 minus 10. Now, what this means is the numbers we obtained inside the parentheses will let us know what we want to do. So we have 7 and 7. We're going to compare that. If and only if the number in the parentheses is greater than the price, that means it's a good candidate to work with. But do not forget, sometimes we could have an 8 here, okay? But we have a 6 and 8. So the difference is 2 and the difference is 1 here. So even though the parentheses could be greater, it doesn't mean it will always be the optimal solution. So you always want to get the greatest difference, the one with the greatest parentheses value. When you subtract the price from the parentheses, you want to get the greatest value, basically. So this will be, the difference is 0. Over here, the difference is positive 2. The difference is 0, and the difference is 0. So our candidate is 6. What we believe is 6 will be a good candidate to work with to get the most optimum cost, because 8 is greater than 6 and there is nothing else that has a greater parentheses difference. So now that we have this, what we will do is you're gonna put a dot here, okay, and draw a line from 6. Go to the first allocated value. The first allocated value is 6 with 20. Now go up or down. It doesn't really matter where you go. So let's go up. And the second unallocated value is 3. Then we can go to 5 and we can come back. Okay, this is a circuit. Well, there are different ways to make a circuit. Okay, we can go to different allocated sources, but for the sake of simplicity, this one is a very easy one, relatively. So what you will do is, since we're choosing an unallocated source 6, we're going to put a plus here because we want to put supplies into 6 because we believe 6 is a cheap option. And you're going to put the neighbors a negative, and this one will get a positive. Okay, so it goes positive minus, plus minus, plus minus. That's just how it works. So as long as you find one positive or negative, you're just gonna alternate between negative and positive signs. So now we're gonna go in this circuit, go look at the allocated versions, the negatives actually, more specifically. We have 5 of 20 supply and 6 of 20 supply. We're gonna compare the supplies. Which one has the smallest supply value? Well, in this case, they're the same, but what we will do is we're gonna choose this smallest supply value. Okay, so if this was a 10, we would choose a 10. If this was a 5, we would choose a 5, as long as it has to meet both of them, basically. So we're gonna choose a 20 because 20 is the smallest value in common. And then you're gonna add 20 because we subtracted 20, so we would keep the balance of the rows and the columns. And this new updated version will help us get our cheapest solution, and we will test that momentarily. So let me draw this again with the updated values. Now I updated this chart, and as you can see, the supply and the demand are working perfectly. We changed this little circuit 5663, and everything is still working. Every column and every row is satisfied. So we did not make a mistake during the along the way. And now, since we picked the cheapest option, we can now compare the prices. So the prices for this one will be 80 because 4 times 20 is 80. 3 times 30 is 90. 6 times 20 is 120, and 20 times 3 is going to be 60. So we will have 200 and 150 here, so we're gonna have $350. So as you can compare this to the previous graph, the previous version had $390. So we were able to save a cost of $40 using this method.